in many activities in life involving movement of rotation. Subtopic: Center and angle of rotation. Rotation is a concept that is applicable in many activities in life involving movement of objects and machines. Examples include pulleys, car wheel, arms of clocks, wind vane, bicycle wheels, among others. When the coordinates of an object and image are given, to get the center and angle of rotation, the following steps are important. Join two object points to their corresponding image points, that is, A to A1 and B to B1. Construct the perpendicular bisectors of the line segments A1 and B1. The point of intersection of the two perpendiculars gives the center of rotation. Mark it as point O. Read off the coordinates of O. To get the angle of rotation, join either A to O, object line, and O to A, image line, or B to O and O to B1. Angle AOA1 or BOB1 is the angle of rotation. The angle of rotation is measured from the object line through the center of rotation to the image line. If the direction of the object line to image line is clockwise, the angle is negative, and if it is in an anticlockwise direction, the angle is positive. Example 1. Triangle ABC has coordinates A 2, 3, B 2, 1 and C 3, 1. After rotation, it has its image in triangle A1, B1, C1, whose coordinates are A1, negative 3, 2, B1, negative 1, 2, and C1, negative 1, 3. Plot on the same axis triangle ABC and triangle A1, B1, C1. Find the coordinates of the center of rotation. State the angle of rotation. Describe the rotation. Solution. On the Cartesian plane, plot the points A, B, and C. Join the points with line segments to form the triangle. Plot the points A1, B1, and C1. Join the points with line segments to form triangle A1, B1, C1. Join A to A1, B to B1. Construct the perpendicular bisectors of AA1 and BB1. With center as A and radius more than half of AA1, draw the first arcs below and above the line with the same radius, and center A1, draw the second arc to intersect the first arc at points X and Y. Read off the coordinates of the point of intersection, that is 0, 0. To get the angle of rotation, joining A to O and O to A1. The angle formed is angle AOA1 as shown below. The angle AOA is the angle of rotation and is measured using a protractor. Form OA through center of rotation to OA. The direction the angle is measured is anticlockwise and is 90 degrees in an anticlockwise direction. Therefore, the angle of rotation is 90 degrees or positive 1/4 tan. Example 2. Triangle ABC with coordinates A 2, 3, B 2, 1 and C 3, 1 is rotated to triangle A1, B1, C1 with coordinates A1, 6, 1, B1, 4, 0 and C1, 4, 0. Solution. On the same axis, plot triangles A, B, C and A1, B1, C1. Join two objects to their corresponding image points. Construct the perpendicular bisectors of AA1 and CC1 as in example 1. The point of intersection of the perpendicular bisectors is the center of rotation. The point of intersection of the perpendicular bisectors is 3, 0. Mark it as point P. The center of rotation is P, 3, 0. Order of rotational symmetry. Reflection. A line of symmetry divides a shape into two identical parts. Worked examples. The shapes below have a line or lines of symmetry. Draw the line or lines of symmetry for each of the shapes. A house, a rectangle, letters D, C, A and E, and scalene triangle. The line or lines of symmetry shown in each shape acts as a mirror line such that each part of the shape is a reflection of the other. The line or lines of symmetry shown in each shape acts as a mirror line such that each part of the shape is a reflection of the other. The line or lines of symmetry shown in each shape acts as a mirror line such that each part of the shape is a reflection of the other. Note, if a shape only matches itself once, it is not considered to have rotational symmetry. Examples of shape which have no rotational symmetry are scalene triangle and arrow. There are two types of symmetry, line symmetry and rotational symmetry. We have covered line symmetry in reflection. If you can rotate or turn a figure around a center point by less than 360 degrees and the figure appears unchanged, then the figure has rotational symmetry. Therefore, rotational symmetry is when you can turn an object positions in which it looks exactly the same. The number of times it fits and looks exactly the same gives you its order of rotational symmetry. Worked examples. Find the order of rotational symmetry for the shape below. Solution. Since this shape will match itself 3 times as it is rotated, it is said to have rotational symmetry of order 3.